Alright, so let's see how quickly we can put together this MikeMike case. I'm starting with the PCB. Which I imported, I think from a DXF. Actually, I think it's an SVG. Yeah, SVG. And then extruded up to, I think, 1.6 millimeters. And all of this is going to be in millimeters, unfortunately. I don't know, engineering with millimeters just makes more sense. It's not very anthropocentric, but whatever. So the point is to rebuild the MikeMike case, which was originally a little slide case. And the original is over here. And I'm having weird issues with it, and it's not fitting the way that I want it to fit. And I'm realizing that I stopped. I kind of forgot how I put it together and why I put it together. Like this edge right here. This edge is supposed to meet this edge, but it doesn't. And this edge is not supposed to meet this edge, and it sticks out. So it's basically a slide case for MikeMike for the circuit board. And it works out like this. And the case itself is just fine. It just needs a few required clearances to support different connectors on the back there. But there's some improvements that could be made. And the more time I spent improving the original, the more difficulty I had and the more I was scratching my head. So we're just going to start from the beginning and see how quickly we can do this. Pull on a Zonde here, I pull away from the mic to breathe. Alright, so we're starting with the MikeMike circuit board. These are support holes that are cut out, which are a smart idea for any of your projects. However, let's see, you can kind of see that support hole. However, the support hole being right here, and the slide direction being like this, it slides in this direction, means that I've got a bunch of solder joints that are going to be right in front of that. So it's kind of a bad place for that, something to plan ahead for. This should have been down here, and this should have been up here, and maybe that'll happen on the next version, I don't know, but it's not important right now. So we've got our circuit board, and I would like to make, well, first of all, I'm going to cheat a little bit because I did figure out these dimensions. This circuit board height, the clearance that's in this area, this dead space, is important. So I happen to know this bottom part is 2 millimeters, and the height on this circuit board, how high it is, this is TinkerCAD. I'm not sure if you guys are familiar with it. This is my guilty pleasure for when I actually want to do something really fast, just kind of bang out some CAD and not have to worry about it being super parametric and reusable and all that. So TinkerCAD is something I use, unfortunately, rather frequently, but it's just so intuitive. And yeah, I know it's hosted on an internet and you can't download it and whatever, but just, I recommend it. I don't like recommending it, but I recommend it, okay? It's fun to even just mess around with. It's very simple. So this measurement, this height that this circuit board is at, is 10 millimeters. So I'm actually going to make a copy of this. Color that one green. We're going to go up 10 millimeters. And as you can see, this number changes, but also this number over here. And if you've just changed it, you can click here, type in 10 and hit enter, and it'll adjust. And that allows you to make very specific, down to the thousandth of a millimeter adjustments. Even though I think this is only 2 significant digits, but whatever. Excuse me. So here's our circuit board, hovering where it needs to be. This thing was our original copy of the circuit board, but the base needs to be 2 millimeters. So this square dragger is actually something that extrudes. So I'm going to change that to, Control Z, undo. Change that to 2. There we go. And I'm actually going to remove the holes from here because I just want this to be a shape of the circuit board without the mounting holes. So let's ungroup. Ungroup. And as you can see, in TinkerCAD, these shapes are accomplished by combining actual shapes and what are called holes. So you create a hole, and then you combine it with a shape, and hey presto, you get a shape with a hole cut out of it. I'm just shift selecting these and delete. Now we've got a plain face right here. Should be exactly the, well, not exactly the height, it should be, what is it, 1.6 millimeters, so that one's 2 millimeters. And now I'm dragging it down. And that makes sense because this is at 0. Let me undo that. Alright, so we're still at 10, right? Yeah, still at 10. This one should be 2 millimeters tall, and it is. And it's exactly in the same footprint. So what I want to do is add probably 1 millimeter, actually probably 2 millimeters. Let's give 2 millimeters edge around the circuit board. And there's a couple ways to do this, but the way I like to do it is the easy way. So I think if I extrude in this, or if I stretch in this direction, if I hold shift, it stretches in ratio. If I hold alt, yeah, if I hold alt, it stretches both sides. Let me undo that. There we go. And this actually has the same thing where it changes, it shows you the delta. So I'm going to hold alt, 1, 2. It actually doesn't show me the delta. Okay, I was wrong. So we're going to look at our horizontal length, and that's 66.68. And we're going to hold alt and extend to not 60. We're going to extend to 70. We're going to add 2 millimeters because if I extend 1 millimeter, is that right? What just happened? Control Z, undo. Okay, there we go. Right, 66.8. We're going to add 2 millimeters because we're extending 1 millimeter on one side and 1 millimeter on the other. This actually will be a little bit easier to visualize if I move this down. There we go. Actually, you know what? Let's just do both on both sides here. Alt Shift, got 66.68. I'm going to add 1 millimeter and 2 millimeters. That's 4 millimeters. Oh, that worked. That's surprising. Alright. So now I've got 2 millimeters. Actually, I've got 2 millimeters on the long side, not on the short side. So we do have to do 66.68 plus 1 millimeter plus 2 millimeters. I'll grab one over here. Can't see the number. 47, 48, 49. That's not right. Am I not a smart? I'm doing 2 millimeters on both. Yeah. Right. So here we've got a nice edge, just a little bit of bonk coverage. And now we'll put our circuit board back to the appropriate height. 1 to 10. Alright. Now we've got our base. And so we want to rebate on this. Let's put that back down. Let's make it, yeah, that looks right. Let's make a duplicate of this. We'll go back to the original size. I think that's it. Not quite. It's just a little off. I'm not sure why. So I'm just going to duplicate this circuit board again. This one back up at 10. There we go. And this one will give a 1 millimeter lip let's remove our holes again. Hey. There we go. And we'll give that 1 millimeter and Alt-Shift resize. Oh, that's interesting. This actually might be why I was seeing issues with this one. It doesn't appear to resize the same directions on an Alt-Shift resize. That might explain why I was having issues with the last one. Anyways, let's go down 1 millimeter. That's actually 0.5 millimeter because we're doing 65 on both sides. No, I was just dragging one side. Never mind. 65, oh, 64. Oh, that's not right. 65, 64. Undo. You see some of the significant digits get lost on some of these resizes. And then since this is the downside of not doing it parametrically. What on earth? You see that? Look at the shape. It rotated. This edge is right here. And now the edge is over here. So TinkerCAD, huh? You're talking about how much I like it, right? Literally. 65, 68. Is it 65 reduced to 64? No. I see what you're doing. 65. But it's so much faster, you see. Yeah, I'm eating my own words here. Alright. 47.63. Change that to 46.63. And then on this side, 46.63. We'll change that to 45.63. There. So now we're going to use this as a cutout for the inside, the internals. And you go back to, this is our hole. It needs to be 2 millimeters up because the device itself is, it's not 1.6, it's 2, there we go. Alright, so you kind of see how this is going to work. The circuit board's going to have that outside edge and then this inside edge cut. Whoops, screwed that up. See, this is what I'm talking about, the mouse. Mouse is imprecise. If it was parametric, I would be done. That's not true. I would still be shaping this all out. All right. So here's our case. This is going to be our hole, essentially. I'm going to extrude this upward. That looks good. Like I'm moving my head, like I'm turning, like I'm looking around the back side of it. That helps. That helps when you're doing this stuff. All right. So now we're going to extrude up to, oops, I said extrude. 1.62. Now we're 0.2 above the circuit board. 0.6 or 0.4 above the circuit board. And I kind of want to go to the height of the buttons, which I might have already measured. But height of the button edge so that we can do like a plate thing if we want to. And the height from the base to the plate mount is, that's probably 0.2. Yeah, it's probably 0.2. That is one of the good things about having these standard imperial unit measurement calipers. Is when you get a measurement that was something for something created in Imperial, and then your measurement is really close to a round number, you can pretty much just assume it's that round number. But we still need to point to our millimeters. So 0.2 inches into millimeters, 5.08. All right. That means our height here should be, well, now it's above the circuit board. The circuit board is 10 millimeters up plus 1.6, which means the height of this should be 10 millimeters plus 1.6 plus 5.08, which I'm not going to do the math for. Let's say 5.08, 10 plus, and then 1.6 plus, yeah, 16.68. Now we extrude this up, 16.68. Cool. And now it's completely blocked off because my internal cut doesn't have an opening for the front. So I can't just extrude this forward, because if I do that, this angle gets messed up. So I'm actually just going to make a copy of it and move it forward. Duplicate that, move it forward. Then we'll combine these. Good. And now we'll make this shape a hole. We'll cut it out of the orange shape. Ta-da! The total height of this, 16.68. And let's just do a little sanity check here. Well, 16.68 millimeters, and we'll change that to inches. So 0.656. That means that 0.656. That should be right about perfect. That looks good. Sanity checks are important. So now we're going to cut out of this the slide for the circuit board. And, well, yeah, let's just make a duplicate and another duplicate. We'll move one of those duplicates out and leave the other duplicate where it is. Because again, if we cut it out here, we'll lose this edge. So if I turn this into a hole, it'll just be captive, which might be interesting, but it's not really what we're going for. Take both of those, turn those into holes, and combine them with this orange piece, the body piece. So there we go. This is the original circuit board. We actually might want to add a couple. Yeah, let's do that. That one's a hole, this one's a hole. We're going to add 0.4. So if I extrude up, it's actually going to be a little less, unless I extrude in both directions. So 1.6, let's add, I mean, 0.2 of a millimeter is a little tight. Let's add an entire millimeter. So let's go down 0.5 millimeter and then well, we're cutting in both directions though. Tell you what, let's combine these shapes. Sometimes TinkerCAD takes a little bit to catch up. These should still be holes. Oh, I pushed the wrong button. Yeah, group them, not ungroup them. Alright. So now we'll take this and we'll duplicate it. So now we've got two of these slide rail cutter things that we want to move. And the first thing we're going to do is extend this one up 0.5 millimeter, which would be 2.1. Extending upward direction, 2.1. And now we're going to cut that. Good. The original cutter still has the bottom, the same bottom as the circuit board. And we're going to move that one downward. And you see we're extending in different directions based on the camera angle. So if I go this way, the extrusion takes place toward the camera. So 1.6, we're still extruding down an extra half a millimeter, so that would be 2.1 again. There we go. And now we'll combine that with the body. And hey presto, we've got 1 millimeter of clearance in both directions, assuming the circuit board stays in the middle, and I should probably give it a little bit on the edge. I don't know, it might be a tight fit. I might like that. Yeah, let's try that. So let's start here and see how that works. So that's already saved. I'm going to go ahead and, just because I want this to be part of the unit when it's completed. So MikeMike relies, or I'm sorry, TinkerCAD relies on a combination of shapes, grouping of shapes, removing shapes from other shapes. So if I just delete this and then save it, I no longer have a circuit board object in here. I still have these cut objects, which might still be useful, but I would rather have the circuit board just floating around in there. So even though there's no contact in the cutting surface, I'm still going to take this original circuit board, make it a hole, and then combine it with this. This actually won't remove any material. And we'll see how that works, because when I come back to this, if I want to mess around with it, I want to be able to pull up that circuit board again, and I can. All I have to do is ungroup, and it takes the last ungrouping, the last grouping that took place, and removes it. So it's like a history of grouped objects. And if you do a lot of grouped objects, this will get very, very slow. So it is highly recommended that you save or export complicated objects as an STL, and then once you have it as an STL, you re-import it, because that simplifies the geometry. Instead of telling TinkerCAD to combine the last 10,000 shapes you made, you've collapsed those 10,000 shapes into one finalized STL 3D object, and now you're taking it out and putting it back in as a single object. So that's a hot tip for TinkerCAD. But I think we're just about done here. There you go. That looks a little weird. Why does that look weird? Looks like we've got a little bit of an edge here. This right here. It's got a little bit of an offset. That's where the cut took place. And yet there's not another one over here. So it can get a little sloppy sometimes, and that's not a huge deal. It's just a little disconcerting. But for something like this isn't, you know, super high tolerances. And again, it's not something that really needs to be parametric. Yeah, you can see this little edge here. I am interested. Why did this happen? So one of those cutting circuit boards that I made and then extruded forward, when I pulled it forward to extend to cut to the edge of this lip, it resized slightly. So obviously TinkerCAD, very useful, good for quick stuff, but still wanting in some ways. So that was quick, allegedly. I see 24 minutes plus explanation. I'm gonna call that pretty good. And we'll see how this looks. It's a little bit chunky. I don't know. We'll see. I can, that's the other thing. I can come in here and ungroup all of these objects and break it back down to where it was before, and then resize one thing and then reassemble it. It's very useful, quick, you know, kind of quick and dirty stuff. But we'll see how this comes out. 24, like I said, 24 minutes, not bad. And hopefully some introduction to TinkerCAD. Highly recommend it. It's fun to play around with and very, very accessible. So it is very uncomplicated. Highly recommended. So I'll print this out and see how it goes.